All right, I really want you to do this first. Like, I really want you to do this first. This is the most basic of all the review assignments, and I really want you to try it first, okay? All right, here's the answers, but you try it first. What's the limit as x approaches 6? Here's 6 from the left, from the right, and the answer is the y-coordinate. That doesn't matter. Right up there, where they have it, where that hole where they jump over. So the answer, the y-coordinate there, the answer is 3. What's the limit as x approaches 4 from the right? So here's 4 from the right at 4. The answer again is 3. At 4, it does not exist because the right does not agree with the left. At 8, so both sides are going to negative infinity, or you could also say does not exist. This is the right end behavior. So the right end behavior is going to 0. At 2, right here, the left and the right both agree that the answer is 1. Is f continuous at 2? Yes. Is it differentiable at 2? No. We have a corner or a cusp that the left and the right don't agree what the answer is for the derivative. Is it continuous at 6? No. Does the derivative exist at 6? No. It can't exist where it is discontinuous. It has to be continuous for the derivative to exist. Number 11, does f at 6 exist? Yes, there's a point right there. It exists, so there's a value there. So the answer is yes. How about f at 4? Well, f at 4 is what? Yep, the solid point, not the hole, is -1. How about f at 6? Again, the solid point, that's at 1. All right, let g be this integral from 0 to 4. Use the function graphed above. So g at 4 would be from 0 to 4. So what's above is f, right? So if I integrate from 0 to 4, that's what it's asking, can you find the area from 0 to 4? So there are two triangles, half the base times the height. One is above and one's below. So we don't need to simplify it. The base of the first triangle is 3, and the height is 1. Subtract. The bottom triangle, the base and the height are both 1. 1 and 1, and it's done. What's the derivative? Well, when you take the derivative, they cross out. So I just left with f at x. What's the derivative at 2? So in other words, what's f at 2? So look off the graph. What's the y-coordinate at 2? The answer is 1. What's the second derivative? Just follow this pattern. So the second derivative then is the derivative to both sides. And then this would mean the derivative at 1. Now, derivative off a graph means the slope. So at 1, what's the slope? Up 1 and over 2. And you have the derivative there. Number 19. Find the relative extrema of g from 0 to 4. So g is here. The extreme would be the derivative, which is f at x. We need to know the critical values, which is at 0 and where it's undefined. So we're going to draw a number line from 0 to whatever number that is, 11. And what are the numbers? So this is what I'm looking for. So where is it equal to 0? So at 3, where is it? It's not undefined here, not undefined here. At 8, that's it. Oh, from 0 to 4. Ha. Well, it's just at 3 then, from 0 to 4. Be a better reader, right? There it is, from 0 to 4. Then what am I looking at? Where is it above and below? So from 0 to 3, it's above, and then after 3 to 4, it's below. And that's going to be what? A max, right? Because it goes from positive to negative. Find the points of inflection from 0 to 4. This time I'll go 0 to 4. So the points of inflection is the second derivative, which equals the first derivative of f at x from 0 to 4. And so what I'm looking for is turning points. So I'm looking for here, and we have one turning point at 2, and it increases and then decreases. That creates a point of inflection at x equals 2. And this is your reason, right, that you can see that the derivative changes signs, the first derivative changes signs. All right, integrate g at t squared if you take the derivative of this, then you plug in t squared, but then the hook, the derivative of that creates the hook for the fundamental theorem of calculus. So we need a 2t at the end as the hook. 23. J at x is a function defined from 0 to 4, so the derivative of j at x is equal to f at x, so which is graphed above. So we're looking at the derivative above. So if j at 2 equals 5, it's a starting value problem. Then what's 3 is we integrate from 2 to 3. We're going to integrate j at x, which is really f at x. So when I integrate this, I just need to find the area from 2 to 3. Did we already do that? So the area from 2 to 3, just a little triangle, that's 1/2, right? Times 1 times 1. That's 1/2. So the triangle, and 1/2 times 1 times 1 is just 1/2, so it's 5.5. If j at 2 equals find j at 0. So again, we're starting at 5. We're going to integrate from 2 to 0. Now, how does that change anything? I should have put a dx at the end here, sorry. When the bottom number is bigger, it's the same area, but you just change the sign. So from 0 to 2, right, is this triangle half the base times the height, and just change the sign to negative. So it's going to be negative because you're going to have to change the sign, and then half the base is 2, and the height is 1, and you have your answer. Almost there. 25. Here's h at x. What's the derivative of that? So this is fundamental theorem of calculus. The derivative in that cross out. This is going to plug in for t. So we go 1 over the cube root of x, this, right? And then we need the hook. So the derivative of that. That's x to the 1/3. So the derivative is 1/3 x and subtract 1 to the exponent. So we can't forget the hook comes from the bounds, the limits. So we plug in for t, and then the hook is the derivative afterwards. 26, what's the derivative at 8? I'm not going to make it complicated. Just plug in 8. You could simplify that if you had to, because you know the cube root of 8. Here, when you take derivative in that, they do cross out, but the top bound, so plug in x squared for t, and then the hook, which is the derivative, subtract. Now you plug in the bottom bound, and the hook, the derivative of that, and it's done. That's it. I'm done. Those are the review assignments. I'm so proud of you for doing all 23. You are incredible. Thank you. Don't give up. Keep working. This was the shortest one, so there's your little gift. Mr. G Math. Till next time.